Let's start by learning about Rolle's theorem and see how it leads to the mean value theorem. Rolle's theorem is a special case of the mean value theorem, and it's easier to understand the mean value theorem after learning Rolle's theorem. I'm going to start with just a general idea of what Rolle's theorem is, and then we'll get into the mathematical definition. Rolle's theorem states that for any continuous and smooth function over an interval, if the function starts and ends at the same value, there's at least one point where the function's instantaneous rate of change is equal to 0. Let's now look at the mathematics behind Rolle's theorem, and I'll connect it to the graph that I have down here below. Rolle's theorem says let f be a function that satisfies the following three hypotheses. 1, f is continuous on the closed interval from a to b. 2, f is differentiable on the open interval from a to b. So notice it's continuous on the closed interval and differentiable on the open interval. That just means it doesn't have to be differentiable at the endpoints. And then number 3 tells us that f of a is equal to f of b. That just means that the function has the same value at both of the endpoints. Let's now jump down to our graph before we get to the conclusion of Rolle's theorem. Here's a and there's b. That's the interval that we're working with. And then we have f of a equal f of b. That just means that this point has the same y value as this point. Now let's jump to the conclusion. Going back up to the green box, it says there is a number c. This number right down here is on our graph in the open interval from a to b such that f prime at c is equal to 0. All that means that at c, the derivative is equal to 0 and the slope of the tangent line is horizontal. The reason that Rolle's theorem is a special case of the mean value theorem is because it's required that f of a is equal to f of b. In the mean value theorem, that requirement isn't there. Let me just put this theorem into a context that maybe you can understand, especially if you've ever been on a roller coaster. So imagine a roller coaster that starts and ends at the same height. Most roller coasters do. If the track is smooth and continuous, the coaster must reach a point in between where it's moving perfectly level, not climbing or descending. That just means that the slope of the tangent line of the track is equal to 0. This just means that the instantaneous rate of change, or the velocity at some point along the roller coaster ride, is equal to 0.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.